This is C-5 Galaxy. This is C-17 Globemaster III. And this is C-130 Hercules. These three transport aircraft are responsible for more than 95% of the airlift missions of the U.S. Air Force, forming a complete airlift system. Looking at their size, it measures 75 meters in length, 20 meters in height, and has a wingspan of 68 meters. Its maximum cargo capacity is around 130 tons. The C-5 is a strategic airlifter, primarily tasked with transporting military supplies between U.S. homeland and military bases worldwide. Because it carries heavy loads over long distances, it requires high-quality runways and can only land on paved surfaces. It mainly performs rear-area logistics tasks far from the front lines. Currently, there are 52 C-5 aircraft in service, making it the big brother of the U.S. Air Force's transport fleet. Next is the C-17. The C-17 is 53 meters long, 16.8 meters tall, and has a wingspan of 50.8 meters. Its maximum cargo capacity is around 77 tons. The C-17 is a strategic and tactical airlifter. This means that it can perform long-range strategic transport missions, rapidly moving troops from the homeland to rear military bases to meet strategic deployment needs. Thanks to its excellent design and short takeoff and landing capabilities, the C-17 can land on various unprepared surfaces. It can land on runways as short as 900 meters, making it ideal for tactical transport missions from rear bases to the front lines. Currently, there are 222 C-17 aircraft in service, forming the backbone of the U.S. Air Force's transport fleet. Finally, the C-130. The C-130 is 30 meters long, 12 meters tall, and has a wingspan of 40 meters. Its maximum cargo capacity is around 19 tons. The C-130 is a tactical airlifter, primarily responsible for short-range transport missions on the front lines. It has minimal runway requirements. As long as the surface isn't too rough, the C-130 can fly. With the addition of rocket boosters, the C-130's shortest takeoff distance can even be as little as 230 meters. This capability is invaluable in the harsh conditions of the front lines. Currently, there are 277 C-130 aircraft in service, making it the most agile force in the U.S. Air Force's transport fleet. Now, how did U.S. Air Force airlift, represented by these three aircraft, gradually take shape? And how did these three planes undergo rigorous selection to become the backbone of the airlift fleet today? In 1948, in Berlin, the United States, the United Kingdom and France were the first to implement a currency reform in West Berlin, aiming to stabilize the chaotic German economy and counter the Soviet Union. This led to a sharp decline in relations between the Soviet Union and the Western powers. In June, the Soviet military blockaded all ground and water traffic to West Berlin, triggering the first major international crisis of the Cold War era. As time passed, conditions in West Berlin worsened. The city's food and coal supplies were cut off. West Berlin needed 35,000 tons of food, milk, coal, gasoline, and other supplies every day. It seemed there was no way to deliver supplies to the residents of West Berlin. On June 29, 1948, the Allied forces unveiled a new plan. They decided to launch an unprecedented airlift operation to supply essential goods to West Berlin. The Soviets believed it was impossible to supply a city with a population of 2.5 million people solely through air transport. Such a massive flow of goods would have to rely on railroads and highways. Therefore, the three air corridors to West Berlin were not closed, which gave the Allies an opportunity. However, the plan was not as simple as it seemed. It required a massive fleet of transport aircraft. The U.S. military deployed 225 C-54 aircraft and, together with other Allied nations, began the airlift. Over the course of a year, they made 278,228 flights, delivering 2,326,406 tons of supplies to Berlin, including fuel and food. The original plan was to deliver 3,475 tons of supplies daily, but by the spring of 1949, the actual number often doubled. On one occasion, a single day saw a record delivery of 12,941 tons. As time passed, the effects of the airlift began to show. By April 1949, the amount of supplies delivered by air even exceeded the amount that had previously been transported by rail to the city. The success of the Berlin airlift rendered the Soviet blockade meaningless. As a result, in May 1949, the Soviets lifted the blockade on West Berlin. This monumental airlift victory made the U.S. military deeply realize the critical importance of transport aircraft. On the battlefield, logistics and supply are of paramount importance. If the U.S. military wants to build a global combat system and increase its military deployments worldwide, then having a large fleet of transport aircraft is a necessary condition to achieve this goal. At this time, most of the U.S. military's existing transport aircraft were old, World War II-era models, equipped with piston engines. These aircraft were already limited in range, speed, and cargo capacity. As a result, there was an urgent need for a new aircraft to take on this responsibility. On February 2, 1951, the U.S. Air Force released a general operational requirement for a new transport aircraft, referred to as the GUR. Simply put, the plan called for a multi-purpose transport aircraft. that could handle the harsh conditions of frontline battlefields and be capable of carrying a variety of vehicles, directly driving them onto the plane. 5 major aerospace companies participated in the bidding, with Lockheed's proposal leading the competition. Initially, Lockheed's renowned engineer, Kelly Johnson, was not optimistic about the project. He believed that if Lockheed took on this project, it could very well destroy the company. He had no interest in such a slow, unarmed aircraft and boldly stated that it was the ugliest aircraft he had ever seen. If you're unfamiliar with Kelly Johnson, you only need to know that top aircraft like the P-38U-2 and the State Route 71 were designed by him. His opinion carried significant weight within the industry. However, Lockheed's president, Robert Gross, did not heed his advice. Instead, he believed that this aircraft would not only meet current needs but also shine in the future. Looking at it today, the C-130 has undoubtedly achieved all of this. The first C-130 made its maiden flight on April 7, 1955. And since then, it has firmly occupied the production line, continuing production to this day. Even the C-130J is still in production, making it the longest produced military aircraft, spanning over 70 years. The C-130 has developed dozens of variants, with missions ranging from transport, electronic reconnaissance and long-range search and rescue, to armed strikes, firefighting and aerial refueling. Basically anything you can think of, it can do. Of course, the primary roles remain frontline transport and armed strikes. When it comes to frontline transport, the C-130 truly shines. This brings us to some of its impressive maneuvers. Landing on unprepared surfaces is just basic operation. Beach landings, grassland landings, those are nothing to brag about. With skis, it can even land on ice. But the most impressive feat was landing on an aircraft carrier. In November 1963, the C-130 completed 29 takeoffs and landings from the USS Forrestal aircraft carrier, including 21 non-arrested landings and 21 unassisted takeoffs. They tested carrier operations with various loads, with the aircraft's total weight varying between 38 and 55 tons. This remarkable achievement set several records. To this day, the C-130 remains the largest and heaviest aircraft ever to land on an aircraft carrier. Based on the massive amount of test data collected from these experiments, the U.S. Navy concluded that the C-130 could transport 11.3 tons of cargo, fly 2,172 nautical miles, and successfully land on an aircraft carrier. Its exceptional performance completely impressed the Navy. However, the U.S. Navy ultimately decided that the transport mission was too risky, and chose the smaller C-2 Greyhound instead. But this is enough to demonstrate the C-130's unparalleled takeoff and landing capabilities. If you add rocket boosters to the mix, the C-130 would truly become a spacecraft. It can perform feats like vertical takeoff and landing, as well as ultra-short distance landings, things that no other transport aircraft can do. Thanks to the C-130's exceptional adaptability, during the Vietnam War, the U.S. military developed a special airdrop system for the C-130. This system was called LAPS, or the Low Altitude Parachute Extraction System. In most areas of the Vietnam War frontlines, the terrain was complex, and large aircraft could not take off or land. Traditional airdrops couldn't accurately deliver supplies to target areas. So, the US military developed this ultra-low altitude airdrop method. In simple terms, the aircraft would open its cargo door while flying just above the ground, dropping supplies. The supplies would then deploy their parachutes, slowing them down and bringing them to a gentle stop. The difficulty with this method is that dropping heavy cargo at ultra-low altitudes causes the aircraft's center of gravity to shift dramatically, making it difficult to control. Moreover, there's a high chance the landing gear will touch the ground. If the aircraft were too delicate or hard to handle, this mission would be nearly impossible to carry out. But only a rugged aircraft like the C-130 could take on such a task. All in all, when it comes to tactical transport aircraft, the C-130 is incredibly outstanding. No matter how harsh the frontline environment is, it can quickly, steadily, and efficiently deliver supplies. This is why it has withstood so many trials and hasn't been eliminated. With the perfect tactical transport aircraft in place, it was time to consider strategic airlifters. In 1960, during the peak of the US-Soviet rivalry, tensions between the two superpowers were constant, and war could break out anywhere in the world. At this time, the US military had a massive fleet responsible for combat logistics at various military bases. The largest transport aircraft at that time was the McDonnell Douglas C-133 turboprop, which could carry over 50 tons of cargo, already an impressive aircraft. However, it wasn't quite sufficient for intercontinental transport. They needed a massive aircraft, one large enough to carry nearly all types of cargo, weapons, and equipment, and to deliver them rapidly to any part of the world. At the same time, the emergence of the N-22, which became the largest propeller-driven aircraft, greatly stimulated the Pentagon. In 1964, the Heavy Logistics Transport System CX program was officially launched. Boeing, McDonnell Douglas, Lockheed, General Dynamics, and Martin, 5 companies, entered the bidding process. Pratt & Whitney and General Electric then entered into an engine competition. After a year of intense competition, in 1965, the Pentagon announced the winning bid. The future heavy transport aircraft would be built by Lockheed, with General Electric handling the engines. Both companies immediately began working on the aircraft's construction, creating the largest aircraft the US military had ever seen. In March 1968, after 2.5 years of work, the C-5 Galaxy was officially unveiled. At 75 meters long, 20 meters high, and with a wingspan of 68 meters, this colossal aircraft shocked the world. It became the largest aircraft in the world at the time. The C-5 was equipped with highly advanced flight instruments, autopilot and navigation systems, and an internal fault detection system consisting of 600 sensors. All key systems are designed with redundancy. The hydraulic system alone has 4 parallel working units. To get this giant airborne, General Electric brought out their best expertise, using the latest technologies and materials to design the revolutionary TF-39 engine. This high-bypass turbofan engine significantly increased engine air intake, fuel efficiency, and thrust. Each engine provides 20 tons of thrust. During engine testing, the B-52 bomber was used as the flying platform. Just 2 engines could provide the same thrust as 8 engines on a B-52. With 4 engines, the C-5 could soar through the sky. Only this kind of abundant power could enable the C-5, this giant, to unleash its terrifying capabilities. The focus of any transport aircraft is always its cargo hold. The C-5's cargo hold is 5.8 meters wide, 4.1 meters high, and 37 meters long. The Wright brothers could even carry out their first flight inside the C-5's cargo hold. The cargo floor is specially reinforced to carry heavy loads, and can be quickly flipped to the side with pulleys for easy loading and unloading. During the loading process, the main landing gear of the aircraft lowers, while the nose landing gear retracts backward, putting the plane into a kneeling position to get closer to the ground. A hydraulic device then lifts the nose, and the rear dual doors open, creating a ramp. This transforms the C-5's cargo hold into a massive 2-way hangar. Staff can simultaneously load and unload cargo from both ends of the aircraft. The C-5's maximum cargo capacity is 130 tons, with a maximum takeoff weight of 418 tons. Most of the US military's weapons and equipment can be easily handled by the C-5. It can carry everything from the Stryker, Apache, Black Hawk, and Super Stallion helicopters to M1 Abrams tanks, M2 Bradley infantry fighting vehicles, Humvees, M109 howitzers, and more. It can carry up to 36 pallets, 4 times the capacity of the C-130. During the Fourth Middle East War, to support Israel, the C-5 fleet made 145 flights over 32 days, delivering 10,800 tons of supplies to Israel. On average, each flight transported 74 tons of supplies, including the tanks and howitzers Israel urgently needed. These supplies were often immediately put to use as soon as they landed. With significant US support, Israel gradually gained the upper hand and won the war. This aid operation perfectly highlighted the importance of the C-5. Only such a large strategic transport aircraft could complete long-distance heavy cargo transport in a short time. During the Vietnam War, the coordination between the C-5 and C-130 was seamless. The C-5 would transport personnel and supplies from the US mainland to rear military bases, where the cargo would then be offloaded and transferred to the C-130s. The C-130 would complete the final transport leg to the frontline battlefield. This division of labor was highly successful, and particularly effective during large-scale transport missions. However, in some specific transport scenarios, it became too cumbersome. Therefore, by the late 1970s, the US Department of Defense sought a new transport aircraft that could meet both types of transport needs simultaneously. On the tactical level, the new aircraft was required to be able to land not at major airports, but directly on the front lines, saving the step of reloading cargo and significantly reducing transit time. This made the first task of the design team clear: to make the new aircraft strong and durable enough to reach forward airstrips, while having short takeoff and landing capabilities. Since the runways at frontline airports are generally only about 1 kilometer long, this was crucial. Strategically, the aircraft was also required to meet the needs for large payloads and long-range operations. It had to be capable of delivering heavy materials such as tanks and helicopters directly to the front lines. In 1981, Boeing, McDonnell Douglas, and Lockheed began competing for the new transport aircraft project. 8 months later, McDonnell Douglas won the contract. The Department of Defense required that the new aircraft be ready for service within 6 years. However, building this aircraft proved far more difficult than anticipated. Due to the demanding performance specifications in the bidding process, many military officials believed it was a waste of billions of dollars on a project that was destined to fail. Initially, McDonnell Douglas planned to conduct test flights within 22 months. But after a year, they realized it would be impossible to complete it so quickly. New problems kept emerging, and costs kept rising. The project quickly exceeded its budget by $500 million, which led to opposition from Congress.
C-17 is a $40 billion boondoggle, and according to my friend Ed Jenkins, nothing more but a town car for the Air Force.
On September 15, 1991, in Long Beach, California, the C-17 was ready for its first public debut. Senior Air Force officials were present to support this project, which had been stuck in a mire. This first flight was crucial for the C-17, as it directly determined whether the project would continue. The 100-ton giant moved onto the runway to begin takeoff. The good news was that the C-17 successfully took off, reaching its planned cruising altitude and flying over the mountains before landing. However, the success of the first flight didn't resolve all the problems. A year later, during static tests, the C-17's wings experienced failures. At 128% of the maximum design load, the wings bent and various malfunctions occurred, falling short of the requirement to perform at 150% of maximum load. On top of that, there was an oil leak near the engine mount. As a result, McDonnell Douglas had to invest more money to redesign the aircraft. In July 1995, at Charleston Air Force Base, McDonnell Douglas had its final chance to redeem the aircraft. 8 C-17s were put through 30 days of rigorous testing, with test pilots flying non-stop day and night to push the C-17 to its limits. The tests included airdropping various supplies, landing in desert environments and unloading tanks, and performing all possible extreme tests. In the end, the U.S. Air Force found that the C-17 met all the requirements and exceeded expectations in many areas. It was successfully introduced into U.S. Air Force service. The C-17 Globemaster III has a maximum takeoff weight of 285 tons, with a maximum cargo capacity of around 77 tons. It has a service ceiling of 13,700 meters and an empty range of 11,600 kilometers. Equipped with 4 Pratt & Whitney F-117 turbofan engines, each engine provides 18 tons of thrust, giving the aircraft immense power during takeoff. It can almost climb vertically from the ground. Its maximum speed is 830 kilometers per hour. It is equipped with 12 fully carbon composite brakes, along with large flaps to alter airflow and provide additional lift. In addition, its uniquely designed engine reverse thrust system allows a fully loaded C-17 to stop within 500 meters. When reverse thrust is engaged, it even creates mini tornado-like vortices at the engine outlets. When the C-17 needs to land on a temporary runway in sandy conditions, the 4 Engine's reverse thrust systems direct the exhaust upwards, preventing the intake of any debris that could damage the aircraft. Such difficult takeoff and landing conditions place high demands on the landing gear. The C-17 is equipped with a robust landing gear system, including a single-column nose landing gear, with 2 Dunlop tires, and 2 tandem double-column rear landing gears, each with 3 wheels per column. In total, it has 14 wheels, with each tire weighing nearly 170 kilograms. A sturdy, heavy-duty aircraft like the C-17 requires extensive logistical support and maintenance. Before and after every flight, the C-17 undergoes a comprehensive brake system inspection. Each brake component is equipped with an easily accessible wear indicator. As wear increases, the rod becomes shorter, until it aligns with the metal plate, indicating it's time to replace the brakes. Every 180 days, the C-17 undergoes a comprehensive 4-day inspection to identify and eliminate any potential defects. To facilitate the loading and unloading of cargo, the C-17's floor can easily be reversed to the side with pulleys, allowing for the use of K-type loaders to handle large palletized cargo. It can also carry various combat vehicles, such as Humvees, M1 tanks, and M109 howitzers. In terms of personnel capacity, after filling the middle of the cargo hold with seats, the C-17 can accommodate up to 140 combat personnel. Additionally, the C-17 can be used as a flying hospital, equipped with medical-grade oxygen, temperature control, call buttons, and features like multi-layered stretchers not found on other aircraft. The multi-layered stretchers can hold up to 12 stretchers, which means it can carry up to 48 casualties. Overall, as a strategic and tactical transport aircraft, the C-17 perfectly fills the gap between the C-5 and C-130. Together, these 3 aircraft form a strong transport triad, covering nearly all transport scenarios. Each aircraft excels in its respective field and is irreplaceable. This is why other U.S. military transport aircraft have been phased out. However, it is worth noting that the current trend in U.S. military equipment development emphasizes multifunctional, versatile aircraft. If one aircraft can do the work of 2, the economic benefits will be significantly improved, with reduced costs. Since the C-5 has already been discontinued, the U.S. military plans to retire all C-5s by 2040. Undoubtedly, the C-17 will gradually take over the C-5's duties. However, the C-17 cannot replace the C-130's role. After all, there is no transport aircraft more durable, cost-effective, and rugged than the C-130.